Okay, I hear the recording in progress. I'll share the screen. All right, so if you want to start putting stuff in the chat for problems you want me to go over, you may, while I do my usual spiel. Okay, so I finished everything we need to for this test. So coverage is 10.1 and 10.5. As soon as class is over, you may start submitting the homework, but I will accept it up to half an hour after the exam tomorrow. So usual rules apply. We're here, we're just doing our review. Okay, so test tomorrow. I will send the exam a little bit after 8 o'clock, or right around 8, 8:01, 8:02, something like that. Find it on Canvas announcements. And then you join the Zoom session. Again, joining the Zoom session is mandatory this time. All of the regular meetings are optional. Some of you join every day, some of you don't, some of you come half the time. That's okay. I don't take attendance, but I will take attendance for the exam. So you have to show up for the exam. As usual, have your camera on, true background. Keep yourself muted. If you have any questions during the exam, just send it in the chat. I'll close the exam at 9 o'clock tomorrow morning, and then you have until 9:05 to take pictures on your cell phone, and you have until 9:30 to submit the homework. But if you want to submit the homework early, like even right after the test, you may do that. Okay, and that would be our fourth test. Remember, you get to drop one exam, but only one, and we only have one exam after that, but that's our longest. So it's not even November yet. Well, I guess after tomorrow's test, that's the end of November. So we have all of November and a little bit of December to do the last chapter. Of course, as you know, once November hits, we have all these holidays. There's a Veterans Day holiday, we got Thanksgiving, and then before you know it, we're done, right? Yeah, I'm not sure if I still have the exam on Thursday the 9th. I may want to move it back, but maybe not. We'll see. This was originally meant, if we had met face-to-face, then I'd have to hurry up and try to grade your exam so I can give it back to you on Friday. But since we're virtual, it doesn't really matter anyway. Okay, so I may want to move back the exam. Now, I'm not promising I'll give you the exam back right away, but that's going to be okay. Even if I give you email you back your test score on Monday or Tuesday, that's fine. You'll get on Saturday. Usually I give you the solutions on Saturday, so you study off of that. And our final exam is not until the week after our last meeting, which is the 17th, and you have from 8:10 to 10:40 on that. So you don't necessarily have to have your very score on the exam. I can give it to you Monday or Tuesday even, but you'll get the solutions video for that. So for this exam, I'm not sure yet. It'll either be the 9th or the 10th. We'll see how it goes, but that's where we're headed for now. Okay, so as usual, you get to have your one formula sheet, front and back, put anything you wish. And you definitely want to bring this polar graph paper. It has to be this polar graph paper. If you have any other polar graph paper, I'm not guaranteeing you full credit or any credit because the calculations will be different. It has to be this one. There's exactly 14 circles, 15-degree marks all the way around. So I can judge you on how you divide up the 14 circles that we are given here. Okay, I'll bring a couple just in case you mess up one. So I'll have you graph one polar graph for sure, r equals whatever theta, right? And you do the same analysis we did in class, find a maximum r, what would be appropriate. I'm grading you also an appropriateness. So the maximum was 3. Some of you crammed the whole graph within the first 3 circles. That's not appropriate. You should come all the way out. And my suggestion for that would have been the 15th circle, right? Even though there aren't 15 circles, you go out that far. And I think the quiz, you had to go out to 15 circles there also. Okay. All right, and then after that, yeah, you don't need the polar graph anymore until the final exam. So the final exam, I may give you some polar graphs also. Okay, I think that's it for the introduction for the test. You've already had several tests, so you know my rules by now. And well, some of you had me before, so you really know it, I suppose. So, okay, so any quick questions about the test in general before I take specific problems that I'll do now? I see some of them coming in the chat now. Okay, so let me start reading the chat and seeing what I got. Okay, so Okay, 10.2, 13, 15. 10.2, 13, 15. 10.4, 31. 10.3, 17. How to find the interval. So when finding areas inside the curves. In section 10.4. Okay, it may have to depend on the particular example. So how to find integral 10.4. Okay, maybe I'll address that issue first, although I'm not positive I'm answering your question completely. So how do you find where you're supposed to integrate? So for something like 21, if that's what you mean, it requires you know where the inner and the outer loop is. So you need a quick graph. In this case, you just need to find out when the graph comes into the pole. Okay. So in other words, set 1 plus 2 sine theta equal to 0. And that gives you sine of theta is -1/2 or something like that. Okay, so the graph would come into the pole at, I think it was 7 pi over 6 and 11 pi over 6. Okay, so a quickie graph would be, it came in something like this, 7 pi over 6, 11 pi over 6. This is problem 21, 10.4. If this helps, okay? And the inside loop was this, and then there was an outside loop after that also. So I think the rest of the graph, there was some other thing going on like that maybe. Okay, so this is the inside loop. So your integration would be from 7 pi over 6 to 11 pi over 6. If that's what you mean. And then the formula for area, which is 1/2 r squared d theta. Okay, so I think that's what you mean by how do you find the integral. If that isn't the case, ask me again or ask me a specific question. But that's as much as I'll do for answering how do you find that out. So you have to find out where the graphs intersect, perhaps. Okay, so part of that was where the graphs intersect. So that would be something like 23. Okay, inside the first, outside the second. So how do you know where to integrate from? You got to set them equal, right? So 23, set 4 sine theta equal to 2, and that'll tell you, where to integrate from once you figure out which is the upper and which is the lower function. Okay, but now let me go ahead and do some particular problems now. 10.2, 13, and 15. 10.2, 13. X is e to the t. Y is t e to the negative t. Okay, find the first and second derivatives. All right, see dy dx is dy dt divided by dx dt. And hopefully you put all these formulas on your cheat sheet. All right, so dy dt, product rule, first times derivative of second, plus the second times the derivative of the first, which is 1, over e to the t. So a little bit of touch up. Factor out an e to the negative t. 1 minus t over e to the t. And then it's best to combine these. You can write as either a product or a quotient. I'm going to write as a product. 1 minus t e to the negative 2t. E to the negative t divided by e to the t is e to the negative 2t. And then d squared y over dx squared is the derivative of this with respect to t divided by dx dt. We already found dx dt, that's e to the t. So now I just have to differentiate this. So first times the derivative of the second plus the second times the derivative of the first, which is -1. all over e to the t. Okay, so what should I do? Factor out an e to the negative 2t. So I have the negative 2 times this stuff. So that's negative 2 plus 2t minus 1. If I did that right. Let's see, negative 2 plus 2t minus 1. I think that's right. So grand total of 2t minus 3 e to the negative 3t. You're going to ask for concave up. Concave up means this is greater than 0. Concave up. Second derivative is greater than 0. This is already greater than 0. E to anything is greater than 0. So I just need to make this greater than 0. So 2t minus 3 is greater than 0. So t is greater than 3 halves. So when t is greater than 3 halves, the graph will be concave up. Okay, and then 15 in the same section. It looks like a similar type problem, I guess. X equals t minus ln t. Y is equal to t plus ln t. Okay, so dy dx, dy dt divided by dx dt. And by the way, you don't have to literally write this. Okay, if you just do it, I don't know what you did. And well, I didn't even write it over here for the second derivative, right? So you don't have to write the formula. You know, you don't have to write this. I don't know what you do. Like here, I didn't write the formula because it was too cumbersome. It's the derivative of the derivative with respect to t divided by dx dt, right? So in other words, when you're doing your problem, don't bother writing the formula. I don't know what you did. So you don't have to literally write that down or write that down, right? Page 649. If you were explaining to somebody else who's never seen it before, then I guess, sure, but we're all on the same page. We know what we're talking about. You don't have to literally write the formula down. Just go right to it. I don't know what you're doing. Okay, so let's see. dy dt is 1 plus 1 over t. Whoops. dx dt is 1 minus 1 over t. And you can make it look a little bit nicer if you clean that up. We'll multiply by t over t. So that's going to be what? T plus 1 over t minus 1. And d squared y over dx squared. So the bottom is just dx dt. We already did that. So I just copy this 1 minus 1 over t. The derivative of dy dx with respect to t. So that looks like a quotient rule. Bottom times derivative of the top, which is 1, plus the top times derivative of the bottom, which is also 1, all over t minus 1 quantity squared. Okay, from algebra, this thing is allowed to slide down to this. The numerator is 2t, is it not? T minus 1 plus t plus 1. The ones cancel out, so it looks like 2t over 1 minus 1 over t, t minus 1 squared. And again, I can make it look nicer if I multiply by t over t. So how about 2t squared over t minus 1, t minus 1 squared. Huh, what do you know? That's t minus 1 cubed, is it not? Back to distant focus. All right, so concave up. When is this greater than 0? Well, the numerator is already greater than 0, except for t equals 0. But that's always positive. So I just have to look at the denominator. It's a cube So it'll be positive when t minus 1 is positive. It'll be negative when t minus 1 is negative, undefined for t equal to 1. So I just want t minus 1 to be greater than 0, or t is greater than 1 for concave up. Okay. Okay, I see 10.317, I believe. .317. R equals 5 cosine theta. Find a Cartesian equation for this curve. Okay, so I think we did something like this before. The trick is to multiply both sides by r. We have r squared equals 5 r cosine theta. Whoops, cosine theta. And r cosine theta turns out to be x. Look back at the formulas. Page 659. Put this on your cheat sheet if I've already done so. X is r cosine theta, y is r sine theta. R squared equals x squared plus y squared, and tangent theta is y over x. And this is x squared plus y squared equals 5x. This turns out to be a circle. X squared minus 5x plus y squared equals 0. Excuse me. Complete the square. Take half the coefficient of x and square it. Half of -5 is -5 over 2. -5 over 2 squared is 25 over 4. So we lose focus here every now and then. So 25 over 4, 25 over 4. X minus 5/2 squared plus y squared equals 25 over 4. Okay, so this is a circle. Center at 5/2, 0, and a radius of 5/2. Okay, so that tells you what the graph is. So 10.431. Reminder, we're not actually doing 31, we're doing 31 star. So if you're asking for 10.431, we're skipping that. I change it to r equals sine theta, r equals cosine theta. We're not going to do sine of 2 theta and cosine 2 theta. Find the area of the region lies inside both curves. Okay. So they touch at the pole because they both have a possibility of being 0. And then set them equal to each other. Sine theta equals cosine theta. Divide by cosine theta. Tan theta equals 1. Which means theta is pi over 4 or 5 pi over 4. The other thing that's a little bit tricky is when you solve for this like an x and y, say, oh, I got x. You normally put it in the first spot. Okay? But theta has to go in the second spot. So pi over 4 goes here, 5 pi over 4 goes here. Okay, plug in pi over 4, you have radical 2 over 2. Plug in 5 pi over 4, you have negative radical 2 over 2. But these represent the same point, right? because here you're going to 5 pi over 4, but you're walking backwards. So again, any duplication, you don't have to put it. Okay, so they touch here and here. Right. Now you could graph it more accurately if you want to, but the graphs sort of go like this. So this is the region that you want. Okay, so how do I know which one is which? Well, at pi over 2, sine of pi over 2 is 1. Here's 1, so this is a sine curve. Sine theta. Okay, so if I go out to 45 degrees, and then double the area, okay, so I've got 2 parts. I can split that up. Here's pi over 4. So I'm just going to figure this out and then multiply by 2 by symmetry. And that represents the sine curve, it looks like. All right, so coming up, the area is twice integral from 0 to pi over 4. So when I sweep around, okay, here theta is 0, here theta is pi over 4. I'm going out to the r, which is sine theta. So 1/2 r squared d theta. Okay, these cancel out. Use the formula for sine squared, 1 minus cosine 2 theta over 2 d theta. Put the double angle formulas on your cheat sheet also. Sine squared theta and cosine squared theta. I'll sneak them down here. If you don't remember it, save you some time. Sine squared theta, cosine squared theta. Again, if we were meeting face to face, I'd make you guys memorize it. They both have a 1. They both have cosine 2 theta. They both have a 2. And then I remember the sine gets the minus sign. So sine minus sine, so minus plus. Okay. But I'm letting you put it on your formula sheet. Okay. Quick heads up though, your next calc teacher, if you have to go on to calc 3, your next teacher might make you memorize this stuff. I make you memorize it if we were meeting face to face. And then I'm not sure if your teacher next semester is going to have you meet face to face or not. It's a possibility, it's my understanding, that at least more courses, more classes are going to be back on campus. But if that's the case, whatever, just warning you, your next teacher might make you memorize these formulas. But that's then. Right now, you don't have to memorize it. I'm letting you have a cheat sheet. So anyway. Okay, so I take out the half. Integral of 1 d theta is theta. Integral of cosine 2 theta is sine 2 theta times the opposite of what I would do for the chain rule for derivatives. Chain rule for derivatives, I multiply by 2, so I multiply by a half. From 0 to pi over 4. Okay, what does happen a lot is when you plug in 0, you get 0. 0 sine of 0, yes. Okay, so pi over 4 minus 1/2 of sine 2 pi over 4 is pi over 2. Sine of pi over 2 is 1. Okay, so that's essentially it. I just get a common denominator and stuff like that, I guess. So 1/2 pi minus 2 over 4. So pi minus 2 over 8. Looks like it's my final answer. Okay, and I think I've caught up with everything in the chat. I was not going to start doing the next chapter, so if there's nothing else, we'll just stop. I think I'm okay time-wise. I mean, it's not even November yet, although it will be November, our next regular class meeting, because we, quote unquote, only have 1 chapter left, but we have more than a month to do it. So Monday we'll start 11.1, So we only have one chapter after this. It's a long chapter and there's holidays, you know, interspersed all throughout November. We got Veterans Day and Thanksgiving and all that stuff. Okay, but I think we'll be okay time-wise to finish everything we need to. Okay, reminder, our final exam is Friday the 17th. That's finals week. So our last regular meeting is Friday the 10th of December. So we don't meet Monday, Tuesday, Wednesday, Thursday the following week. I will have some office hours, but our final exam is Friday from 8:10 to 10:40 of 2.5 hours for the final exam. All right, so unless I'm mistaken, I think I've caught up with the chat, but if I'm mistaken, you can put it back in the chat or unmute yourself. Let me stop the share, check the chat again. Whoops. Let's see. Okay, so unless I'm mistaken, I think I've caught up. Again, sometimes it's hard to read the chat and talk to you guys and then try to do the problems at the same time. Ideally, with somebody to help me with that, like if I have a TA to make sure I get the right problems, but I think I've done it right. Okay, so if nobody else has anything, we can call it a day. All right, so if I missed your question, if I read the wrong thing, let me know. Or if there's another question you want me to do, let me know. Otherwise, we're going to adjourn and then just get ready for the test tomorrow. Okay, so anybody else with a question, please? Okay, 10K, I see some more coming in. 10.535. There's something that comes after that. I'm not sure what that means. Unless there's a mistake, maybe it means please, I guess. Okay, so 10.535, okay. I'm gonna guess that's what you mean. 10.425. Okay, so let me see what those are about. Yes, there is a section 10.6. We're not scheduled to do it, so don't worry about that. Okay. Okay, so 10.535. All right, so I think I got some more. $10.535. Parabola vertex is 3, -1, a horizontal axis, and passing through -15, 2. Okay. Vertex is 3, -1. Horizontal axis passing through -15, 2. Okay, so 3, -1, very crudely. Horizontal axis means it's either going to open to the left or the right, axis of symmetry. -15, 2 is over here somewhere. Okay, so it's going to open to the left. Open to the left is y squared equals -4py if the vertex is at the origin. The vertex is at 3, -1. So that's going to be y plus 1 squared equals -4. Oops. It should be y squared equals -4px, sorry. And then parentheses x minus 3. So translate it from the origin to 3, -1. So that's y plus 1 squared, -4p, x minus 3. Find a p, I plug in -15 and 2. So -15 goes here, 2 goes here. So that's going to be 3 squared is 9 equals -4p times, let's see, -15 minus 3 is -18. -4 times -18 is a positive 72. Divide by 72. P is equal to 1/8. So put 1/8 back there. -4 times 1/8 is -1/2. So the final answer should be y plus 1 squared equals -1/2 parentheses x minus 3. Okay, so I think that does it. Okay, 10.425. Time is it? 15 more minutes. Right? 10.425. Inside the first curve, outside the second curve. R squared equals 8 cosine 2 theta. And R equals 2. All right. This says R squared equals 4. So the reason why I'm doing that is so now I'll set these equal to each other. So 8 cosine 2 theta equals 4. Cosine 2 theta equals a half. X coordinate is a half. So this is 2 theta, 2 theta. This would be 60 degrees or pi over 3, negative pi over 3. So 2 theta is plus or minus pi over 3. So take half of that, half of that. So theta is plus or minus pi over 6. So they touch at negative pi over 6 and positive pi over 6. So very crudely, it's going to take a while to find out exactly what that looks like. I know what that looks like. It's a circle, radius of 2, r equals 2, negative pi over 6, pi over 6, r is 2. I plug in 0, 8 cosine of 0. That's 8 times 1 is 8. R squared is 8, so r is the square root of 8 is about 2.8. Okay, so it does come out farther. So this r equals 2, this is r squared equals 8 cosine 2 theta. So this is the upper and this is the lower. Yeah, I drew it funny, but it's supposed to be symmetric. Okay, so the area is integral from negative pi over 6 to pi over 6 of 1/2 upper r squared. Fortunately, they already gave it to me as r squared. 8 cosine 2 theta. I mean, you can say r equals square root, blah, 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 but you got to do r squared anyway. So there's r squared. Minus the smaller r squared, 2 squared is 4. D theta. Okay, and because of symmetry, which I didn't draw so well, multiply by 2, that's convenient because these will just cancel out. 0 to pi over 6, 8 cosine 2 theta minus 4 d theta. So integrate of 8 cosine 2 theta is 8 sine 2 theta times a half minus 4 theta. From 0 to pi over 6. See if I did that right. Derivative of all this is same thing, cosine 2 theta times 2. Yeah, that works out. Oh. Wow, when I plug in 0, I still get 0, I believe. 0, 0, yes. Okay, so I'll plug in pi over 6. 4 times sine pi over 3 minus 4 pi over 6 is 2 pi over 3 minus nothing. Okay, pi over 3 is 60 degrees. Sine of 60 degrees is radical 3 over 2. That's 2 pi over 3. So 2 radical 3 minus 2 pi over 3. And I think that's pretty much about it. All right, I think I've caught up again. So what time is it? 12:02, something like that. Stop the share. Okay, so I think I've caught up. Okay, any other questions, please? Otherwise, we're done for the day. Okay, I'm trying to read what else was in the chat. I think I've tackled everything, but if not, ask again or unmute yourself. Okay. Right. Anything else? Otherwise, we're going to quit. All right, folks, that's it. So see you tomorrow for the test. You may start turning your homework, get your formula sheet together, and you have to join for the test. Everybody has to join for the exam, naturally, as we said before, and have your homework ready by half an hour after the test, but you can submit it early if you wish. All right, that's it for today, folks. Okay, have a good day, and we'll see you tomorrow for the test. Okay, bye, everyone.